So hello everyone. Today I'm going to talk about abort/abandonment metrics. My name is Nicholas. I work in Google Chrome Speed Metrics. And first I want to tell you the brief outline for this talk. I will start by giving some motivation about why we would care about aborts, and then I will give you our current approach to defining aborts, because it has slightly changed compared to the way we were looking at it in the past. After that, I will give you some glimpse into some abort data from Chrome's table channel. And after that, I will provide some topics for discussion on this topic. So let's begin. Consider the following scenario. We land a change that delays FCP, which is first contentful paint. It delays FCP by 2 seconds for half the users and improves it by 1 second for the other half. So if you just look at the data, you would say, well, obviously that change is no good. However, we see that half of the delayed users leave the page before it reaches FCP, simply because it is taking too long and they decide not to wait for the page to load. So even though the expected FCP delta on our graphs is an increase on average, because 2 seconds versus 1 second, right? The actual FCP delta is that the graph does not move at all. So basically the volume changes because some users don't report FCP because they never reach FCP. They just leave the page before it happens. But the actual median, or the values, like the histograms, that they don't change. So this hypothetical scenario is worrisome, right? I mean, maybe you won't make the face like the lady, but it certainly is a cause for concern. So first of all, let's define what we think of as an abort, because this is obviously a very overloaded term. So we need to properly define what we're talking about here. For something to be considered an abort, first we want to explicitly request that this is a page load where the user navigates into the page and away from the page intentionally. Why do we do this? Because a lot of page loads are basically redirects, right? So you go to, well, I don't have a concrete example, but basically you type a URL and then after it loads, you look, it's a different URL. So it redirected. And if we don't exclude those, then the abort rate for some sites will be exceptionally high, because basically it just means that it redirected all the time. So we include only explicit navigations. Second, we consider an abort to be, we consider a page load to be aborted if we did not reach FCP. And by this, I mean at any time. So even if you leave the page while loading and then come back to it, if it reaches FCP at that time, then it's not an abort. If you leave the page before it reaches FCP, then it's an abort. But we also have a third condition, which is that the page must have been in the foreground at some point. So consider, for example, you right-click on a link or middle click so that it opens in a new tab, but you don't change focus to that tab, right? In that scenario, it is possible for the user to later decide, oh, I don't really want to visit this page, and close the tab without ever going into it in the foreground. So we want to avoid considering those cases, because it's simply not possible for FCP to be reached for those cases. So what I'm saying is, for the denominator, we only include page loads where the page was in the foreground at some point. Now, the abort rate is very simple. You just calculate how many aborts there were, and you divide by the number of aborts plus the number of pages that reached FCP, assuming the three conditions above. Now, why FCP? there are several other potential choices for a metric to define an abort. However, FCP is very clear in that the user did not gain any value from visiting the site because nothing showed to the user. There are other options like unload, but unload is not really tied to anything meaningful about the user experience or what the user sees on the screen. You could potentially delay all content to be loaded in the load event, for example, and then you would just reach unload immediately. And there are other possibilities like LCP, but LCP is defined in a way that it only occurs late into the page load once the user actually interacts with the page. So it's not really that easy to define abort in terms of LCP. And inputs, but inputs are not necessarily abandons. So you could, for example, click on a Wikipedia article, see the answer to the question you were looking at, and then just leave the page without even interacting with the page. We don't want to consider that to be an abandon, so input is also not necessarily always an abandon. Now, one caveat about the data I'm about to show to you is that for the purpose of the way we compute when FCP is reported, we have to plumb the data from the render process to the browser process in Chrome. And sometimes that means that the data is not plumbed because we use some delay to basically ensure that the renderer is not reporting data all the time to the browser. So for that reason, some of this data may slightly include like some of pages that may have reached FCP, but shortly afterwards, the user left the page. So let's look at the overall abort data on Chrome's table. And again, I'm using the definition of abort that I mentioned. If you look at the overall data, it shows about 8.6% on Android and 2.5% on Windows. I chose the two most common OSs, at least the largest set of users in Chrome, right? Android and Windows. They also represent two very distinct sets of devices, like mobile versus desktop. So I think it's fairly representative. Now, to look into cases where the plumbing of the FCP does not impact so much these rates, and B, it's more clear that the user intentionally aborts as opposed to, oh, I clicked by mistake, let me just click back very quickly. I'm looking at abort rates when the total foreground duration exceeds a certain threshold. So you can see for foreground duration greater than 1 second, the abort rate drops to 5.3% and 1.8% on Windows. And as you increase the foreground duration threshold, the overall abort rate, of course, decreases. Notice that this includes all page loads. So it totally makes sense that the rate will decrease because most page loads will reach FCP by, for example, the 2-second threshold. So so I just want to clarify, it's not saying that slow pages are aborted less. And to make that message more clear, I also gathered some data for this particular question. What is the question? Sorry. The question is, are slow pages aborted more? So to answer that question, I look at the following set of pages. Imagine pages that start in the foreground and stay in the foreground for at least n milliseconds, and also do not reach FCP by those n milliseconds. I look at, does that page ultimately result in an abort, or do they eventually reach FCP? So I look at the same definition as abort, but restricting it to a specific set of pages that we consider to some degree slow depending on the threshold n. So for 500 milliseconds, as you would probably guess, it's almost the same as the overall abort rate because we're only excluding a very minimal amount of pages, those that start in the not foreground and don't look at the foreground for at least 500 milliseconds. But as n increases, as you would expect, the rate increases. So in 1000, which is basically 1 second, you already see an abort rate of 10.3% on Android and 4.1% on Windows. And as you increase n, of course, you see the rate increases. I did it up to 4000, and then I was like, this is still kind of low numbers. Let's see 10 seconds. What happens if the user stares at the screen for 10 seconds? Do they eventually abort or do they not? The answer is surprising. 33% of users would abort after 10 seconds of staring at the screen, and 14% on Windows, which shows that A, users are pretty patient, but B, the abort rate is very significant for page loads that for sites that have a very, very slow FCP. Because if you think of 10 seconds, it's not that unfeasible in the horrible web performance landscape of these days. So now that I've presented the data, I wanted to hear from folks. And here are some possible questions. Are there ways we can improve this current definition of aborts? For context, before we defined abort by just looking at pages that start in the foreground. So if they went into the background before reaching FCP, we would consider them aborts. I changed that definition because I considered it to be okay if a user starts loading the page and then goes away and then goes back to it and then actually uses the page. I consider that to be okay. But it's, of course, up for debate. Another question, is it worth digging more into the data? And what insights could we get from the abort data? Another question, what are the pros and cons of looking at this new definition of aborts that considers even pages that start in the background versus the one that only looks at pages starting in the foreground? And finally, and very importantly, do we think exposing this data would be useful to web developers, especially with regards to the question of, are they missing regressions because they have no insight into aborts nowadays, and the hypothetical scenario could be occurring for some of their performance data? So that lots of possible topics, and I'd like people to feel free and chime in.
So I have a question. I used to work on some of the very initial abort metrics in page load metrics, and one thing that we really struggled with way back in the day, like this was probably like 2015, 2016, was there were a lot of code paths that could abort page loads or abort navigations that appeared to be user initiated, but would like really skew the metrics. So like a lot of times these came like pretty quickly. So I think like limiting the analysis to like aborts that come after 500 milliseconds or longer probably does a good job about filtering these out. But like we would see things where it seemed like users were like, you know, putting a brick on their F5 key, or like highlighting a link and then holding down enter, and then it's spawning like a billion navigations that constantly are aborting the previous, but they all appear to like have a user gesture. Or like even users double clicking on links because like they'll click the link the first time and it will spawn a navigation, and then they'll click a second time and it will abort. So I'm wondering, like, do we see those in the metrics? I mean, it seems like you don't anymore, because like when you showed that the abort rates after 500 milliseconds, it wasn't that different. But like we were seeing these huge spikes at like 30 milliseconds or like less than 100 milliseconds for aborts. And I'm like wondering if like somehow we fixed all the bugs and now like all of those code paths are now fixed.
So I think Annie was the one who wrote the user-initiated bit. And then we also have a page and recent bit. So we do try to use both. I don't think we cover all the cases in the sense that it's certainly feasible, in my opinion, that some of those cases are still being considered aborts. But Annie, do you have any thoughts on that? Or
yeah, the user-initiated code is pretty like straightforward. So like if it came from the browser and it doesn't have like came from an app flag, we assume that's user-initiated. And then if it came from like an actual event handling from a user input, then we call it user-initiated. And so it's a little bit more correct than like previously. There's the user-initiated that was like, well, was it within n milliseconds of the user action? But looking at the cases you're talking about, like we definitely see like very fast aborts that we think we should throw out, but I don't see like these kind of like spikes, or the data just doesn't seem as inconsistent as like it seemed like it was a couple of years ago. I'm not sure. At first I was like, well, maybe it's because we're focusing on Android and there's less like things you can do in the UI, but we're also seeing lower abort rates on Windows, so I'm not really sure what's happening.
Yeah, I almost wonder if like the changes to user gesture or like the user activation changes might have helped, because like it used to be the case that you would do a user activation and then you could sort of do a whole bunch of events that would appear a whole bunch of navigations that had activation. But I think in like a couple of years ago we removed that and made activation like we made navigation consume activation. So I wonder if somehow like that could be a reason why we fixed this. But yeah, I don't know. I'm very happy that this is no longer an issue and we can like finally sort of trust the abort metric. So yeah, this is very exciting work.
I can't give you like a solid explanation though. I do wonder if the changes to user action might have been better than we noticed.
yeah, I also don't have a super clear explanation. Sorry. Anyone else have thoughts on this?
Oh, sorry. Go ahead, Nicholas.
Hi, I'm Nicholas from the Microsoft Edge team. My camera isn't working. Sorry about that. Okay. So on Edge, I work on navigation-related things. Sometimes we record metrics about top-level navigation success rates. If they drop below a certain level, we go, oh, what's going on? Something, is an error. But a lot of times, the abort error messages or the error code skews that metric, since that seems to be the highest navigation error code we see. Do you ever work with the navigation team on Chrome to kind of understand, is this just a slow page load that is definitely intentional? Or is that kind of like an independent problem from your perspective?
I'm not sure if I understood your question. Sorry. Do you
Basically,
mean
what I'm trying to figure out is like if there's a good way for us to get insights into user behavior such that we don't trip an alarm when we don't need to for our top-level navigation metrics?
Okay, so I would say it's really hard to be super certain about the user intention. So for the purpose of this metric, we, as Annie mentioned, we rely on something that is called the user-initiated metric, which just sets a bit when we are fairly confident that the user did trigger this navigation. But at the same time, it's certainly possible that in some cases it's wrong. And on the other hand, there's also all sorts of filters that we need to do on the data to ensure we don't get bogged down by data that is like due to errors, such as we exclude failed something called provisional loads, failed provisional loads. So we exclude those page loads from this data, and we exclude, for example, non-HTTP navigations, and so things like that. There's a bunch of filters that we employ so that we get only the meaningful data that like we think is useful. I don't know if that answers your question.
Actually, yeah, despite my poorly worded question, that is actually super helpful, because that sort of thing would help us design a more accurate metric where we should actually be worried if navigation start failing. I may follow up with you after this.
Yeah, for sure. And I failed to include the mailing address in this slides, but we have a mailing list at speed-metrics-dev@chromium.org. But you can also reach out to me, and then I will help you guide the query to the relevant folks, because I don't know all the answers either. Oh, there, perfect. Thanks, Annie. All right, anyone else have thoughts?
I guess I have a quick question. Like you just mentioned that you're filtering out the provisional loads, like non-committed navigations. Like, do you feel like that's gonna skew the abort metric? Because like I'm sure there's a bunch of aborts that happen when like the server is just like not responding, or it's taking a long time to respond, and you can't connect.
Yeah, that's a good point. For some of these, it's possible that we want to include the failed commits, but it's also really hard to distinguish those that are like failing on like due to slow server or the other cases, right? So it's kind of a balance between do we want more holistic data, but that will include more noise, or do we want to try to narrow down data a little bit so that we can have a less noisy metric, in the sense that it's more controlled by the parameters and the possible things that can go wrong. So from my perspective, looking at it with the filters that we think can cause noise issues is the better approach, even though, as you mentioned, in reality, the real aborts could even be higher for things like failed provisional loads. So that's a good point. Thanks.
So Nicholas, you were asking about reporting this to web developers. There was talk previously about reporting this through the reporting API. Is that still on the table? Is that still a thing that we want to do? Also, are we looking at just giving them access to the aggregate data in Crocs?
Right. So the current Chrome user experience report policy is that they would like to ideally only report data that can be gathered by web developers themselves. And so right now, it's not really possible for them to gather abort data, at least not in a very non-contrived way, right? Like you can think of ways the server can detect aborts, maybe, but like it sounds really, really hard. So from that perspective, if people think it's actually very useful, I would love to have like a web API for this. But I don't know what's the status on origin policy, which is what I feel we would need for that. Document policy would not be enough, right? Because if you don't have enough chance to show the content, you may not have had chance to show the headers. So the headers need to persist across navigations, which means you need origin policy. And I don't know if that's going to be a thing ever, but if it is, then I would definitely get on board using that to surface some of this data to developers. Yeah.
One additional point about reason why we would want to surface it to developers is we do see like pretty drastic differences in like the performance of a page for the users who did succeed. The faster pages get abandoned far less than the slower pages. So we were hoping that if we made this data more available to individual websites, that that they might be encouraged to make their pages faster, because their analytics are probably not counting these loads right now.
I'm also pretty worried about the impact on our internal metrics. Like the way that we're measuring first contentful paint is probably actually pretty inaccurate, especially when we're looking at high percentiles. If we're looking at the 99th percentile, but 8% of navigations are aborts, the 99th percentile is pretty much meaningless. So that's pretty scary.
Yeah, so even Chrome gets it wrong. Imagine web developers, which have less leeway in terms of what they can get wrong to get meaningful data. So yeah, that's a good point. Thanks. Anyone else have some final thoughts before we finish this session? All right. Well, I will stop the recording then. And thanks everyone for joining.